Good. Okay. So once again, what I was saying was I'm going to start with the closed system examples, and then we'll move to the open system. Now, this water stream, this sour water stream, again, contains about 300 ppm of these volatile gases. But as it turns out, at 25 degrees C in 1 atmosphere, the equilibrium state of this water is such that no vapor phase forms. Therefore, if I wanted to know what the headspace composition of the CO2, H2S, and ammonia were, I would have to somehow add a headspace or force a headspace to form. And the way you do that is straightforward. You essentially force a headspace by adding an inert gas. Here you can see what I've done is I've created a single point calculation in which I've added 20 ppm, there's my 20 ppm, of nitrogen. Now the nice thing about nitrogen is that it's an inert gas. It's the carrier gas of our atmosphere, so there won't be any questions about why we've used nitrogen. And also it's fairly insoluble. So at 20 ppm, I will have saturated the water with nitrogen, and I would have had enough left over to create a vapor phase. And in fact, if you look in the summary section, you can see that yes, I still have my water phase, and I've now created a very small amount of vapor. It's about one part per million of the total system, or it's about 1 million times smaller than the water phase. So the vapor phase is there, but it's very small. And the good thing about it being very small is that I won't be transferring too much of the dissolved H2S, CO2, and ammonia into that vapor phase. So let's take a look at the results.